Welcome to the video for 4.1, the periodic table. If you need to look at your textbook to help with this video, then you need to look at textbook pages 72 to 74. The lesson objectives for today are to describe how the periodic table is organised and classify an element as SP or D block according to where its position is in the periodic table. So the first thing you need to know about is the organisation of the periodic table, which you should know from GCSE, but we'll go over it anyway. So the first most important thing is that groups go down, so they are the columns in the periodic table, and the periods go across. And an easy way to remember this, if a slightly embarrassing one, is that when women have periods, they tend to get cross, so the periods go across. So here is a picture of the periodic table, and you can see that the group numbers are labelled there, so you've got the columns. So on the left hand side you've got group 1, then group 2, then 3, 4, 5, 6, 7. On the right hand side you can see on this version of the periodic table it's labelled as group 0. Now sometimes you'll see this as group 8 and sometimes you'll see it as 0. It doesn't matter which one you use as long as you can understand that both can be used. So the groups, which are the columns, all have similar chemical properties. So if you look at group 1, for example, then they're very similar. Group 1 are the alkali metals, and they're all very similar chemical reactivity. So for example, when you put them in water, they will react with the water to give hydrogen. You'll see the hydrogen gas being given off. And you've probably seen this in your GCSE chemistry lessons. And you should know from GCSE again that in group 1, as you go down the group, the elements get more reactive. And this is because they're trying to lose an electron, and that electron's further away as you go down the group. The outer electron's further away because the atom's bigger. So it's easier to lose that electron, so they become more reactive as you go down the group. Then you've got group 2, which some of you all have met before, and they're called the alkaline earth metals. And they behave similarly to the alkali metals. Then you've got the block in the middle, where you go from, at the top, scandium to zinc, and they're the transition metals, which you'll do in more detail at A2. Then you've got group 3, 4, 5, 6, and 7. The halogens in group 7 we will do in more detail later, and you will have touched on in your GCSE. And in group 0 there, or group 8, you've got the noble gases, which are very unreactive. So group 7 there, which you've done at GCSE, you'll remember that the reactivity of those decreases as you go down the group, so it's the opposite of the alkali metals in group 1. And that's because in the group 7, the halogens are going to gain an electron in order to react. So the smaller they are, the more attractive they will be to that negative charge, that electron that they want to attract. Now on the periodic table there you can see a red line going, starting at the top, going between boron and aluminium, and then between silicon and germanium, and then astatine and antimony. And that red line signifies the barrier between the metals and the non-metals. So to the left of the periodic table, to the left of that red line, you've got the metals. To the right, you've got the non-metals. Now it's a bit fuzzy, that line, because you've got the metalloids like silicon, which have some properties similar with metals and some similar with non-metals, so they're called the metalloids, sometimes called the semi-metals. Now here's an alternative version of the periodic table, and you can see that here we've divided them into the S block, the P block, the D block, and the F block. Now if you think back to your electron configuration, you may be able to work out why they are called these, and that's because the letter for the block represents the letter for the outer electron for that element. So if you look in those first two columns on the left that are rounded in orange, they are the S block. So the outer electron for all those elements is going to be an S. So in the first column, the first group, it's going to be S1, and in the second group it's going to be S2. So likewise the P block on the right hand side, that's outlined in that kind of purpley blue, all of those elements in that block will have their outer electron will be a P electron. Now for the S block is a bit special because you've got hydrogen and helium there. Now sometimes hydrogen and helium are in slightly different places in the periodic table, and that's because they have unusual characteristics. So hydrogen, for example, has one electron, so it should be in group 1 because it's got one electron in its outer shell, its only shell. But it doesn't react similarly to the metal, so quite often it will be around the top of the periodic table floating by itself. And that's because of the difference in chemical reactivities. Likewise with helium, it's sometimes floating around the top, but it should be in the S block because its outer electron is an S, but it doesn't fit there because it's not a metal and its properties are very different. So its properties are very similar to the group 8 or the group 0 elements on the far right hand side, which is why you sometimes see it on the far right hand side even though it's not a P block element. Then the block in the middle is the D block because they have got their outer electrons in the D block, and then we don't really need to worry about the F block, but that's the one at the bottom which is separate from the rest of the block. So I've already talked about hydrogen and helium and why they're separate in the periodic table, so we don't need to go about that in any more detail. What we do need to talk about is the development of the periodic table, because you need to know a little bit about this. Now, you only nearly need to worry about the contribution of Mendeleev, and although there were lots of other scientists who were involved, Mendeleev was the one who's actually credited with the development of the modern periodic table, and he's the one that we talk about a lot in lessons and the one that's remembered in public memory. But there were other people who contributed, but his was the most important contribution. So what he did was he organized the elements in rows according to increasing atomic mass. And he had them in groups of 7. So he had 7 columns, but they also went along in rows, and they increased going along the row by an atomic mass 1. Now there were lots of scientists who tried doing this, but the reason Mendeleev is cherished as being the father of the periodic table is that he did something different, and what he did different was he left gaps for undiscovered elements. So everybody else just got all the known elements and put them in order, and they didn't leave any gaps, whereas Mendeleev left gaps where he thought that there was a break in the pattern. So he left a gap for elements that hadn't been discovered yet. And not only that, but he predicted the properties of those undiscovered elements based on where they were in the periodic table. And when these elements were later discovered, they had the same properties that Mendeleev had predicted. So this led to the periodic table being accepted as a valid scientific tool rather than just some strange idea that somebody had come up with. So here are our lesson objectives again. So as usual, check over them and make sure that you understand them. If not, look in the textbook, look online, watch the video. So you need to be able to describe how the periodic table is organized and classify an element as SP or D block according to its position in the periodic table.